Am I live already? Hi Mel, am I already live? Sure, sorry. Hello Mel, am I already live?
I've said that you're already live, that you can start.
Okay. Hello grade 12. I'm Mr. Mbanga and today we're going to carry on from where I left yesterday. Yesterday I left an equation basically which was about finding the equation of the tangent. But before we look at that question, I would like to ask if there is anyone who has a question, because if I'm not mistaken, there was someone yesterday who was having a question. So if you have a question, you may just please write it on the chat room. Okay, so while waiting for the question, we're going to look at the solution of the problem that I left yesterday. Okay. Okay, Odesha, the correct format is for the equation of the tangent line is x squared plus y squared equal to r squared. This is provided that the circle passes through the origin, which has a point of 0, 0. The standard form of the equation of the circle is x minus a all squared plus y minus b all squared, which is equal to r squared. This is when you have a circle that passes through a center with coordinate a and b. But now when the coordinate is passing through the origin with coordinate 0, 0, that's where you get the equation that you have written, x squared plus y squared, which is equal to r squared. All right, so we're going to look at the solution of the question that I left yesterday. Okay, sorry, let me just. All right, sorry for the inconvenience. Yesterday, here is the question that we had. We had the equation that was to determine the equation of the tangent line that touches the circle defined by x squared minus 2x plus y squared plus 4y equal to 5 at the point minus 2 minus 1. Yesterday, what I told you, I gave you a hint that was for you to find the derivative of this equation. But that one is, I would say, is the second option that you can opt for. You have to use the standard equation that I gave you yesterday, which is x minus a all squared plus y minus b all squared, which is equal to r squared. The derivative part, we're going to see how we do it also, but here is the one that you have to use. You have to use the standard equation, which is x minus a all squared plus y minus b all squared, which is equal to r squared. Now, looking at our equation here, you're going to see that this equation is not on the standardized form that is given, that is this one here. But you're going to see that you can transform this equation here. This equation here can be transformed to be looking at this form. So the first thing that you have to do, you do what we call the completing of the square. You have to complete a square. If you look at x squared minus 2x, you can see that is, when you expand, you can see that is the shortened expansion, the shortened expanded form of x minus 1 all squared. So that's why you can start in here, in this step here, I've written x. In this step here, sorry, I've written x minus 1 all squared, which is x minus 1 all squared minus 1. You're going to start, if you expand this form, it's going to give you x squared minus 2x plus 1. But remember, initially, you did not have the plus 1. So that's why you see that I've added minus 1 there. So we go to y plus 2 all squared. So when you expand again this form, you're going to see that you have y squared plus 2 plus 4y plus 4. So you see that the 4 was not there. That's why I write minus 4. So that's why we write minus 4. And again, it's equal to 5. So now, when you do the calculation, you're going to see that you have x minus 1 all squared plus y plus 2 all squared equal to, remember the minus 1 minus 4 is minus 5. When it goes to the right, it becomes plus 5, and therefore plus 5 will give you plus 10. So you can see that now this form is now in the standardized form that you know, whereby you're going to see that you have your center, which is now 1 minus 2. When you compare this equation to this one, you're going to see that you have the center, which is 1 minus 2, and the radius here, you're going to see that the radius here will be the square root of 10. So you're going to have your radius, which is the square root of 10 here. Okay. So going to the next one. Therefore, the next thing that we have to do here is to get the gradient from the point that is given to the center, which is 1 minus 2. Or you already know how to get the gradient. The gradient here will be, the gradient there will be minus 2. When you do M1, your M1 here will be y2 minus y1 divided by x2 minus x1. Therefore, your M1 here will be minus 1 plus 2 divided by minus 2 minus 1. Therefore, you have the gradient of this, the point between the distance between the point to the center here will be equal to -1/3. Also, we see that to get the gradient of the tangent line, what you have to do, you use the fact that you know that two lines are perpendicular if and only if their product is equal to -1, or you already know M1. Therefore, you're going to see that M2 here will be -1 divided by negative 1 over 3, which is 3. Therefore, you see that the gradient M2 here will be 3. So once you know the gradient, you're going to see you apply y equal to mx plus c, or you use the point that is given -1 and you use -2. The point that is given -1, you use this point -2 -1. Therefore, you substitute y here by -1, which is equal to 3 times -2, 3 times -2 plus c. And you're going to see that c here is equal to 5. And the equation of the tangent here will be 3x plus 5. So that will be the equation of the tangent, which is 3x plus 5. Okay, I see there are some questions. Okay. Okay. Odisha is saying, once you have a number answer, which can you use to represent it? Okay, you can use, once you have a point and you know already the standardized form of your equation, you can just substitute. Remember, you need, in order for you to write the equation of the tangent line, you just need to know the center and the radius. So for you to be able to write the equation of the tangent line, you need to know the equation of the circle. You need to have the center points and also the radius. So basically, that's what you need. The x squared plus y squared equal to r squared, I repeat, is only used for when the circle is passing through the origin 0, 0. All right, so we're going to see now how to calculate how to get this equation based on the derivative that I showed you yesterday. So we're going to see how to calculate that. All right, so if based on this equation, you're going to see that you have dy over dx equal to -2x plus 2 divided by 2y plus 4. Based on, if you look at y2 minus y1 divided by x2 minus x1, basically here, remember that that's the equation of the tangent line. Now, using the derivative, you're going to use now the derivative dy over dx, which is equal to -1. Remember that this is when you must have, this is when, again, the product there must be equal to -1. dy over dx must be equal to -1. So the first thing that you do, you find the derivative of that equation of the circle that is given based on the x, and then you find the derivative of that circle given based on the y. So when you're going to do that, you're going to see that, in fact, dy here will be equal to 2y plus 4, and then dx here will be equal to 2x minus 2. But remember that dy over dx here must be equal to -1. So that's why we have dy over dx is equal to -2x plus 2, all divided by 2y plus 4. Now, when you substitute your point, which is -2 minus 1, you're going to see that you get now the gradient, which is, you're going to see that you get the gradient, which is -2 times, you're going to have -2 times -2 is +4, +4 plus 2, you're going to see that is 6. Now 2 minus 1 is -2, -2 plus 4 is +2. Therefore, when you do 6 divided by 2, you're going to get the gradient, which is 3. And once you know that gradient using that equation, That's where you get again y equal to 3x plus 5. All right, so we're going to move now. We're going to look again at another example. We're going to look at another example here. Okay. Okay, so here is another question, but I would like you to also answer it. I want you to just look at the question and try to attempt it, and by answering, try to use also the social media. So you have x squared plus y squared minus 20x negative 16y plus 139 equal to 0. And the question is to find the coordinate of the center C. Find the coordinate of the center C of the circle. And then B is to show that that radius is in fact 5. And then if the circle is tangent to the line passing through 5, negative 2, determine the equation of the tangent line. So the question is to find the coordinate of the center C, show that the radius is in fact 5, and then if the circle is tangent to the line passing through 5, negative 2, determine the equation of the tangent line. All right. So what you have to do here again, you're going to see that this equation is just written in the similar form as what we just did now. So the first thing that you have to do here, is to write the equation in the standardized form. You have to write this equation, x squared plus y squared minus 20x minus 16y plus 139 equal to 0 to the standardized form, which is x minus a all squared plus y minus b all squared equal to r squared. So once you have done that, you'll be able to get your coordinate and even the radius. So you see that by writing this equation in the standardized form, you will sort out equation A and B. And then once you know already the center and you also have the 0.5 minus 2, you'll be able to determine the equation of the tangent line. All right, so we're going to look at the answer. So as solution, like I said, you have to rewrite that equation in the standardized form. And by so doing, you're going to see that you'll have x minus 10 all squared. If you remember, you had x minus 20x. So that's why we have x minus 10 all squared. And once we add 10, when we raise 10 to the power of 2, we have added 100. So that's why I put negative 100 to just go back to x squared minus 20x. So we go back to y, we also go back to y minus 8 all squared. Now you're going to see that we had x squared minus 16y plus 64. Therefore, it means that we have added 64 and we have to remove it. That's why I wrote negative 64. So plus 139 plus 139 equal to 0. So now you're going to see that by working it out, you will have x minus 10 all squared plus y minus 8 all squared. And then if you look at minus 100, if you look at minus 100 up here, you have minus 100 minus 64 minus 100 minus 64 is negative 164 plus 139. The answer was negative 25. Therefore, when you send negative 25 to the right, it becomes 25. That's why you see that the equation is now shortened to x minus 10 all squared plus y minus 8 all squared, which is equal to 25. Now identifying this with x minus a all squared, plus y minus b all squared equal to r squared, you get the center C, which has coordinate 10, 8, and the radius r is 5. So you see that your center here will have the coordinate 10, 8, and the radius r here is 5. Now, to get the tangent equation, we go back again to find the gradient. So here we already know the center of the circle, and we also know the point that the circle is passing through. So that's why you see that the gradient of the radius line here, we just do -2, -8 divided by 5 minus 10 equal to 2. Therefore, you see that the gradient here becomes -1/2. The gradient of the tangent line. Remember, we said that the product of of two lines that are perpendicular must be equal to -1. So that's why you see that here we're going to have the inverse of 2 is half plus times the -1. That's why you have -half. Now using y equal to mx plus c, it gives you -2 equal to -half times 5 plus c. And when you work it out, your c is half. Hence, y equal to 2x plus half. So that will be the equation of the tangent line. Y equal to 2x plus half. If that's the one that you guys have got, you may also share the answer. The correct answer there is y equal to 2x plus half. Okay, now we're going to move on. Okay, I see there is a question. Okay, Marcelo is asking why y is not equal to -half of x plus 1. Okay, Marcelo. Okay, let's go back again to the question. Okay. Remember, okay, from this equation that we have here from x squared plus y squared minus 20x minus 16y plus 139 equal to 0. The first thing was for you to get the center of this circle. Or getting the center of this circle, we have seen that the center here is now, when you do the working, is going to be -10. Okay, let's go to the next slides. You're going to have -10. Okay, -10. Okay, that's all right. Okay, so we know that, okay, the gradient of the tangent line, okay, we have -10 and we have -8. All right, so we have the point which is also is also 5. Okay, let me go back. Okay, the point is 5 minus 2. All right, 5 minus 2. All right, so we know that, okay, the gradient here, the gradient of the point between the radius and the point passing through the tangent line. Okay, we have seen that is 2. All right. Now the gradient, the tangent, okay, of the tangent line is negative half. All right. So now here we were to find our C. So our C here is, we know that is minus 2 equal to minus half of 5 plus C. Therefore, we'll have minus 2 plus 5 of 2 equal to C. Therefore, we have minus 5 plus 4, minus 4 plus 5 divided by 2 equal to C. Therefore, you're going to see that C is half. All right, so you're going to see that the answer here for the tangent line Y will be equal to negative half of X plus half. That's the correct answer. So you're going to have Y equal to negative half of X plus half. Okay, I see that there are some other questions. Okay, let me just. Okay, let me just look at the question. No, the correct answer there, Y equal to negative half of X plus half. So, Masejo, you just need to add the negative sign in front of half. The correct answer there is negative half of X plus half. All right. Okay, now, sorry. Okay, so here is another question. You have x squared minus 2x plus y squared plus 6y minus 6 equal to 0 with center A, and you have another equation of the circle x plus 4 all squared plus y negative 2 all squared equal to 9 with center B. So the first question is to express the circle with center A in the standard center radius form. And then after that, you determine whether the circle are touching externally or internally or not even touching. So the question is to express circle with center A in the standard center radius form. And then after that, you determine whether the circles are touching externally, internally, or not even touching. Again, you're going to see that for the first equation, you have to write it as the second equation. So again, what you do, you see that x squared minus 2x is the beginning of an identity. Y squared plus 6y is also the beginning of an identity, which by now you are supposed to know. So what you just have to do, you're going to see that x squared minus 2x, since it's the beginning of an identity, you have to find that identity. And to have x minus 1 all squared, which is that identity, and then you subtract the negative 1 that you have added. And then y squared plus 6y minus 6 equal to 0. Again, we have to do the same thing. So let's just look at the solution. All right, so you see that we have x squared minus 2x plus 6y So that will be equal to, sorry, I think this is not the slides. All right, so it's going to be equal to 6. So we have x squared minus 2x plus y squared plus 6y equal to 6. So when you expand, you're going to have x squared minus 2x plus 1 plus y squared plus 6y plus 9. That will be equal to 6 plus 1 plus 9. Now, when you do your calculation, you're going to now see that you have x squared, x minus 1 all squared, plus y plus 3 all squared, which is equal to 16. So now from there, you're going to see that that center that you are looking for will be 1, -3, and the radius here will be in fact 4. So your radius here will be in fact 4. And then the other point B, the center here was -4, 2, and the radius is 3. So I repeat, so here what you are supposed to do, you are supposed to just do the completion of your square. You have to do the completion of the square. So basically you have the equation here is x squared minus 2x plus y squared plus 6y equal to 6. The x squared minus 2x plus 1, this is another step. I think this is just a typing error. So you're going to see that is x squared minus 2x plus y squared plus 6y equal to 6. Now the next step here supposed to say is now x squared minus 2x plus 1. Basically here, this is your identity that actually you are supposed to have. Plus now y squared plus 6y plus 9 that you are supposed to get. Now when you factorize it, you're going to see in fact that is x squared minus 1 all squared minus 1. So that's the one that you see that I've added on the right here. Now, for x squared plus 6y plus 9, you see that initially we did not have the 9, so I've added the 9. So basically, when you are factorizing, it's supposed to be y plus 3 all squared minus 9. So that's the one that I've substituted. But now when it goes to the right, that's why you see that is positive 9. That's why you can see that now when you work out, you're going to have x minus 1 all squared plus y plus 3 all squared equal to 16. Therefore, you're going to see that this is a circle with center 1, -3. So we have our center -1, and our center is 1, -3. So the radius here also will be 4. Okay. Now the question was asked, are the circle meeting? And if they are meeting, are they meeting internally, externally, or not even meeting? So what you have to do here, you have to find out the distance between the two center A and B. So you come here, you find the center, you find the distance between the center A and B. Or you already know, you know that the distance between the two center is going to be, you use 1 minus 4 all squared plus now bracket -3 minus 2 all squared, which is going to give you square root of 52. And then the square root of 52 will give you 7,07. I see there is a question. Okay, so you're going to see that it gives you 7,07. 0.07. Okay, Odesha is saying y is positive 1 and 3. Y is 1 positive and 3 negative for A. The center of the first shouldn't be negative 1 and 3. Okay, Lawrence, I will also answer you. Okay, what is the standardized form of the circle? The standardized form of the circle is x minus a all squared plus y minus b all squared, which is equal to r squared. Now, when you see x minus 1 and you compare it to x minus a, and you know that the center is also a point with coordinate AB. So when you compare minus 1 and minus a, you're going to see that in fact a there is 1. All right. Now, when we go to y minus b all squared and you compare it with y plus 3 all squared, you're going to see that b is in fact negative 3. So basically, you just compare this equation with the standardized form, x minus 1 all squared. When you compare it with x minus a all squared, you're going to see that in fact a there is 1 by just comparing. And when you have y plus b, y minus b all squared compared with y plus 3 all squared, you're going to see that your b here is negative 3. Okay, now the question that is to find out whether the circle are meeting. I repeat again, to find out whether the circle are meeting, we're going to look even that there are 3 instances. For example, we're going to see that that is the node of, this is what we're going to see in the next slides. So you're going to see that here, what I say is that to find out whether the circle are touching or not, you first look at the distance between A and B. That's the one that you calculate. You calculate the distance between A and B. After you have calculated the distance between A and B, you also calculate the sum of the 2 radius. You calculate the sum of the 2 radius. Now, in this case, the distance between AB is going to be square root of 1 minus 4 all squared plus bracket minus 3 minus 2 all squared, which is equal to square root of 52. And the square root of 52 here is equal to 7,07. If now you also look at the radius of circle A and circle B, you have the radius of circle A is 4 and the radius of circle B is 3. You see that 4 plus 3 is 7. Now, the distance AB is 7,07 and the sum of the 2 radius is 7. You see that the distance between the 2 center is greater than the sum of the 2 radius. Hence, we conclude that the circle are not touching. So I would like you to just take this note. You're going to see that now. Let me just go to the next slide. So you're going to see that now when you are, okay, I see that there is a question which I did not attempt. But you're going to see that when you have the distance between the 2 circles, which is equal to the sum of the 2 radius, we say that the circle touch externally. When the distance between the 2 center of the 2 circles is equal to the sum of the 2 radius, we say that the circle touch externally. But now when the distance between the 2 center is less than the radius, the sum of the 2 radius, you say that the circle touch internally. Okay, now when the distance of the two center is greater than the sum of the two radius, you're going to see that the circle do not touch. So this is also important for you to know when the distance of the two circles is equal to RA plus RB. When it's equal, you're going to see that the circle touch externally. Now when the distance between the two centers is less than the sum of the two radius, the circle does not, those two circles do not, they touch internally. But now when AB is greater than RA plus RB, you say that the circle do not touch. Okay, I see, okay, Odisha is okay. I hope also, Lawrence, you have also understood now. So basically, it's important for you to know, these three notes. AB equal to RA plus RB, the circle touch externally. When AB is less than RA plus RB, the circle touch internally. And then when AB is greater than RA plus RB, the circle do not touch. All right. If there are any questions, feel free again to answer, to ask your question. Okay, so I would like you to write also this. I want you to write this is an application, and then I'm gonna leave this one also as homework to you, and then feel free also if you have an answer to also put it on a social in the social media. So here is a problem. It says above here, you can see that you have your Cartesian plane X and Y, and then you have the circle which has a center point P, and then the point on the circle you have R, which is 12, negative 18, and then you also have Q, which is a point on the circle, which is 4, negative 2, as coordinate. Now it says the line given by the equation 3x minus 2y minus 44 equal to 0 passes through its center. The points Q, which are 4 minus 2, and R, which is 12 minus 18, are points on the circumference. Determine the coordinates of P. So remember, this is also a question that you have on the tangent. So here it asks you to find the coordinate of P. You can see that P here is the center. So now we are looking for the center of the coordinate of this center. But you can see as hint that the distance between P and Q is the radius. The same also applies with the distance between P and R, which is the radius. Therefore, you know that a circle here can only have one radius. So it means that the radius of PQ must be equal to the radius of PR. So PQ here must be equal to PR. So you have to find the distance of P. You have to say that PQ, the distance of PQ is equal to the distance of PR. So basically you will say PQ squared will be equal to PR squared. And then from there, by doing the calculation, you should come up with the coordinates of P. So I will leave it as a homework. I've given you already an information how you can find it. So you just use PQ squared equal to PR squared. Remember that PQ squared here is the distance that you are looking for. PQ squared equal to PR squared. But now remember also that the point P has coordinate X and Y. So you can also work out that equation 3x minus 2y minus 44 equal to 0. You just make, for example, y the subject of formula, knowing that is x, y. So you just make y the subject of formula, and you're going to see that P will be only expressed in terms of x's. And then from there, you can be able to calculate the distance PQ squared and PR squared. So tomorrow we're going to see the solution. If you have any question, feel free to contact me directly through my email. I see there is a question. Okay, there is no question. If there is no question, I'm going to leave this question to you as homework, and tomorrow we're going to see the solution. Okay, from the group there is no question. Okay, all right. So